Hello, everyone, and welcome to another day of live streaming with me. It is January 4th and day 4 of live streaming with me. I hope you're doing really well. It's 5 o'clock here in Seattle, and I hope wherever you are, you're having an amazing day. Or if your day is just getting started, I hope it is an amazing day. Let's make sure we are actually live. Nice. Okay, what are we going to build today? So, if you've been following this live stream for the last 4 days, you know that I've been working on an OpenAI app, integrating it with LangChain, Tailwind, DirectUs, and creating a real estate API. So, today I'm going to use that app and build a recommendation engine. I've never built a recommendation engine before, so I don't know how well it's going to go, but we'll do our best shot. Meanwhile, let's make sure that we are live in all of the places. If you're joining me live, please send me a message in the chat telling me, hello, you are here. So I know that my voice is actually audible. Cool. I feel like it is working everywhere. Nice. Okay, let me share my screen. I'll show you what we're going to work on today. So, some of you may have seen this app already by now, but if you haven't, let me describe this again. So, this is a real estate app where I instead of looking for a property by entering filters on things like Zillow.com, where you have to enter like 40 different filters together to get something meaningful. Instead of entering like 40 different filters on a UI to get something meaningful, we can instead just write a sentence and get LLM to parse that sentence for us and get JSON out of it, which we can send to Zillow API. So I'm going to demo that for you right now. So let's say you say, I'm looking for a 5-bedroom house in Seattle in the range of 2 million to 5 million. Um, and that's it. That's all I'm going to give. And that I want to see like a list of properties that match this description, and that's all I'm going to give it, right? So if I hit search, oh wait, is my server started? It is started. Okay, see, so I'm starting to get properties already. This is a $2.49 million house in Seattle. This is the address, which is 14 bedrooms. Holy shit. 3 bedrooms, a lakeside property, looks beautiful. And so I got like a list of houses that match the requirements that I sent, and I didn't have to write any filter. I didn't have to create any filter. I was literally writing a sentence. Now, yesterday, what we implemented was a nice to have feature. So I can say something like, with a backyard, a front yard, lake view, and nice and a good school district. And let's also give it a good walking score. A high walking score and a good school district. So I'm just specifying some more nice to haves, and this is how we are going to build a recommendation engine, because these nice to haves are going to help us filter these or rate properties to match our requirement. And so now, if I search, you will see that what we've done yesterday was that we added this nice to have property where now I get things like backyard, front yard, lake view. It still wasn't able to get a high walking score. Sometimes it's the problem of like the prompt that you're passing in. If I pass this, let's see what it says. Nice to haves, our lake view. Oh yeah, it wasn't able to find that high walking score is a nice to have. But that's okay. We can fix that. What about if I remove this and good school district search? Oh, yeah. So that works. Somehow, high walking score, it doesn't understand what that means. And that's just working with LLMs. Okay, cool. So, yesterday we implemented this like button, which, if you click on this like button, it would save this to the database, which we are using Directus as our database. So, if I click on like and go back to my database, which is here, and I reload this, hopefully I am logged in still. Let's get 250 records. Where's my property? Oh, there it is. Um, I think this is the one, because yesterday I left it at um, dislike button, because I think I was doing a dislike. But anyways, I think this is the property that we added, 8849 35th Avenue. So that's the one. Now let's also implement a dislike button so that when I can like it or I can dislike it. And that would set this check mark or cross in our database. So that will give us kind of like a base to start off our recommendation engine. So let's go ahead and do that. Okay. Um, let's implement a dislike button. So I already have a like button. I'm just gonna literally copy this, paste it, and say dislike. Dislike, preferences false. Okay. Now if I go to my API, I don't like how this looks, so I'm gonna give it a flex. What is this div? Let's give it a flex. Div class name, and I'm using Tailwind here, so adding a flex is super easy because I know which class name it is. Okay, reload this. Oh, fill description, search. Mm, is flex column not the one? It's a flex row. There you go. Okay, and then this is kind of in the center, like it's kind of on the left. I wanted it to be in the center. Let's fix that. Or is it align items? Or is it align center? And then justify center. There you go. Okay. So let's do that. Justify center and align center. So it's nice and centered. That looks good. So let's also make sure that this works. Some of these don't have bedrooms and bathrooms, and I don't know why that's happening. I think it's probably just the data that's coming back. Hopefully, there isn't a parsing error. Okay, let's hit the dislike button on maybe this one because it looks too small. So this is 509 North 66th Street, dislike it. Now, if I check my database, is it already updated? Reload my database. Oh, go back. 509 66th Street. That is disliked. Perfect. It works. Cool. Okay, so that gives us a good base to start a recommendation engine. And now we're going to start a recommendation engine. I have never worked on this, so I don't know what to do, but we will find out. Meanwhile, if you are joining here live, please tell me where you're joining me. Hello, Aditya from India. So nice to see you here. What time is it in India? It might be like 6:30, 6:44. Super early morning for you. What is your Sunday plan? I hope you have a restful Sunday today. One thing that I'm noticing is that the quality on Twitter is a lot nicer than the quality on YouTube. Is that true? I feel like the video looks a lot more crisp in Twitter. This is being live streamed on YouTube, Twitter, and Twitch at the same time. No, just go to sleep after the debugging session. Oh, nice. What debugging session? Are you talking about this or something else? Okay, meanwhile, let's find out how to do a recommendation engine because no idea. Maybe we should just add ChatGPT. Actually, I'm gonna open this in OpenAI. So if I can find one of those, OpenAI. If I remember correctly, I think I've seen a tutorial on building recommendation engine in OpenAI. Ooh, there's an article itself. This could be helpful. Tutorial for creating recommendation engine. That's literally what I need. Writing a recommendation engine. Okay, let's read this. No, let's read. This person says, do you Google search on collaborative filtering and content filtering? These are the OG recommendation models. These two are examples that come up in a quick search for me. Interesting. Here's an example from the OpenAI cookbook that you can use to understand underlying methods. Oh, this is helpful. Open source examples, of match. Okay, let's look up this collaborative filtering and content filtering. Meanwhile, I will close this and close this and close this. Okay, let's read this article. I'm going to share this in case you're interested in reading it yourself as well. I also don't know if people on Twitter can see the text that I'm posting. So if you're on Twitter, watching this on Twitter, tell me if you can see the text that I'm posting because I don't see it in the chat message. Twitter's live stream is kind of weird. Okay, let's read this. So this is interesting. Content-based filtering based focuses on the characteristics of the items themselves. It recommends items similar to those a user has previously shown interest in. So, for example, if you've watched thriller movies, the recommendation system is going to show more thriller movies within the thriller genre. By honing in on inherent characteristics of the items, such as the genre, author, or artist, the system ensures a more targeted and content specific recommendation strategy. Interesting. Collaborative filtering is user centric. It analyzes patterns and similarities in user behavior to make recommendations. So both these people read the same article and they're kind of similar. So if it was read by the first, we recommend it to the second. I think this is kind of helpful in shopping experiences, but for our experience, I believe content-based filtering is what we need. Hybrid techniques. Oh, hybrid techniques ingeniously, ingeniously integrate the strengths of both content-based and collaborative filtering to enhance recommendation accuracy by leveraging a dual approach that approaches incorporates both items, attributes, and user preference patterns. This method adeptly tackles inherent limitations present when relying solely on each approach independently. Hybrid techniques are particularly effective in providing refined and diversified recommendations. Interesting. I think diversified is kind of a keyword here. The rise of large language advanced content recommendation approach. The rise of LLMs has significantly streamlined various tasks, notably the evolution of recommendation systems. For modern recommendation systems, the conditional dependence on content or collaborative filtering has given way to a more sophisticated approach. Harnessing the power of semantics, modern recommendation systems navigate and explore linguistic meaning to propose related items. Kind of inflated text, but what they're trying to say is um, modern recommendation systems depend on content and collaborative filtering. The conventional dependence on content and collaborative filtering has given way to a more sophisticated approach. So it's more sophisticated than just content or collaborative filtering. Harnessing the power of semantics, which I don't know what those semantics are, modern recommendation systems navigate and explore linguistic meaning to propose related items. What does it mean to explore linguistic meaning? Let's find out. In this blog, I will show you how to build a modern recommendation system with this advanced approach. Let's first take a look at the tools required for the system. We'll use the OpenAI text embedding model. Let's open that. My scale is a vector database and TLDB 5000 movie dataset in this project. Right, I'm going to open all of these to see what we are looking at. Vector embeddings, I think this will be really helpful because we have to transfer our data from like this JSON object into a vector object. So this will be really helpful for that. Then what is this? My scale, the SQL vector database for scalable AI. Okay. They're using this database for AI purposes. Um, I'm using directors. I don't know if it can store vector, but we'll find that out later. And then the data set, which is the data set that they're using to populate their recommendation. And for us, it's gonna be the properties that we're liking or disliking. Okay, loading the data. We have two key CSV files, this and this. That's the data set that they're using. Credits and movies. Where is this DMD movie data set? This is this one. It's crazy how much data there's in this. It says 4761 unique values. Okay. These files contain essential information about a diverse array of movies, which will form the basis of our recommendation system. So I guess for us, the first step is to create that data set because we only have 5 items. So I'm going to create this here, recommendation engine. Step one, create a data set. Which basically means liking and disliking some of the properties for creating properties. For liked and disliked properties, which means that I have to go ahead and like and dislike some properties. Okay, next step. By the way, is this legible? Let me know if this text is too small or if I should zoom in. Okay, data pre-processing. Data pre-processing crucial for ensuring the quality of recommendation system. We'll merge the two CSV files and focus on the most relevant columns, title, overview, genres, cast, and crew. This step is about finding data to make it suitable for our model. So step two is clean up data or pre-process data. I don't think this would be helpful for us, but ensure data set has relevant fields, which is city, address, number of bedrooms, bathrooms, nice to haves. Because I think for us, we have to think about what the nice to haves are because Because when you're looking for a house, it's more than just the number of bedrooms and bathrooms in the house. It's what else the property offers. Like, does it have any views? Does it have any back? Does it have any a good school district? What is the walkability score? What does the neighborhood look like? So I think the nice to haves are kind of important. So let's also write down um, step 2.1 is clean or like present or like parse nice to haves in JSON. Because as of now, it is actually just a it's just a string array. What is it here? Backyard, front yard. So it's just a string array, but we need to be able to kind of parse this out of the property that we're viewing so that we can kind of create a list of next to have that property has. That's what will help us differentiate one property from another property. So we have to create parse nice to have in JSON from the property listing. This is January 4th, 2025. Feels so weird writing 2025. Okay. All right. Actually, you know what? I'm going to create a new file because let's keep this clean. New file, todo.md, and this will be moved into todo.md. There we go. Hold on. There we go. Command X. That's better. Clean, clean. All right. Right. What are we doing? Right. Pre-processing. Okay. So we got that. This step is about refining the data to make it suitable for our model. So we've got that. Parse nice to have in JSON from the property listing. Generate the corpus. What? Next, we generate a corpus for each movie by combining its overview, genre, cast, and crew into a single string. So what is this DF? Credits.merge. What is DF? I think they were using DF somewhere. Is your data frame and it has the columns overview, genres, cast, and crew. Okay, let's find out what is data frame. What is a data frame? Data frame is a two-dimensional data structure, like a two-dimensional array or a table with rows and columns. Pandas. What is pandas? So it seems like it is a Python distribution. What about JavaScript? What do I have for JavaScript? I should create a Python backend. Generate corpus, overview genre. This. I think this article doesn't do a very good job of kind of as explaining the assumptions. Oh wait, it is a MySQL thing, so why am I surprised? Okay, where is it? So they generate the corpus, which is generate a corpus for each movie by combining its overview. This comprehensive information helps the system make accurate recommendations. Then they get the embeddings. We then use Open AI's embedding model to convert our corpus into embeddings. This is when they're converting into vector, which are numerical representation of the movie's content. So by getting the vector representation of the text, we can now apply semantic search easily using MyScale. So, okay, we were here, data pre-processing, then generate corpus, which I don't know, I still don't know what that means. But then after that, we need to create vector embeddings. This is step 3, and then this is step 4. Okay, and then setting up my scale, then store vector in the database, store vector in database. Then what? Creating a table. Now we create a table according to our data frame. All the data will be stored in this table, including the embeddings. So I guess that's just creating a table within the database, which is MyScale. Um, SQL statements create a table, name movies on the cluster, the constraint, make sure that the vector embeddings are of the same length, storing the data and creating an index in MyScale. In this step, we insert the process data into MyScale. This involves batch inserting the data to ensure efficient storage and retrieval, which makes sense. Um, the process data. Okay, so they're creating a table in the database, then they're putting the data itself in the database. Okay, this is where we do the stuff, generating movie recommendations. Finally, we create a function that generates movie recommendations based on user input. This function gives the exponential decay factor to give more relevance to recently watched movies, enhancing the recommendation quality. I think that's really helpful. Um, so from genres for I train genres input into genres that append genre. Okay, embeddings is this. Convert to numpy array, decay factor, adjust as needed for exponential decay. Result is client.query distance embeddings as distance from default movies, order by distance. Display the results. Oh, so I think it's just the distance factor that's helping. And this distance factor comes from, where's distance coming from? Oh, is distance like a SQL thing? I don't know what distance is here. As distance as dist from default movies, order by distance limit 10, display the results, ask the user to select a movie, which is the input. Selected movie is this, get the embeddings to selected movie title, so you get the embeddings, apply exponential decay and update combine embeddings, okay? Normalize the combined embeddings. Interesting. Okay, so let's summarize what we saw. Um, if I enter a genre, then there is this exponential decay, which is helpful because it helps to rate the recently rated movies as higher in recommendation as opposed to the other ones. Results is this print recommended movies. So then it just selects from the movies and select a movie. So then if the user selects a movie, they get its embeddings and then apply exponential decay and update combined embeddings. So then they apply the recently selected movie and use the decay factor to update the rest of the embeddings. Hmm. Normalize the combined embeddings. Okay. We explored how to combine LLMs with vector database like MySQL to create a content recognition system. Selecting the right vector database is very crucial for any efficient application. MySQL excellent handling, structured metadata, ensuring fast and accurate query responses, its ability to scale efficiently guarantees strong performance even as datasets expand. Interesting. Good article. But I think there's a lot more kind of stuff about vector embeddings that I'm not familiar with. So I'm going to spend some time learning that. First, let's talk about collaborative filtering. And I think content based filtering, because I think that's more relevant to us. So let's learn about content based filtering. So here is the next article we're going to read. Content based filtering. Show on stream. How about that? Hopefully, this doesn't cover my face. Does it? Nice. You don't stream on Twitch. I am streaming on Twitch, Pinak. I am streaming here. This is being streamed on Twitch as well. This is the Twitch URL. If it's not live on Twitch, please tell me because I can see it on Twitch. So hopefully you can see it too. Okay, so this is the article we're reading right now, content-based filtering. Let's go through this. I'll try to minimize this. Okay, so what is content-based filtering? Content-based filtering uses item features to recommend other items similar to what the user likes based on their previous actions or explicit feedback. Hopefully this is zoomed in enough. If it's not legible, please let me know. Cool, cool. Found you from Learn with Jason's channel. Oh, yay! Thank you. I loved being on Jason's stream. It was such a fun experience. Pinat, did you watch the web dev challenge or something else? Because I've been on Jason's stream a few times. So tell me where did you see the recent web dev challenge where we created an app, Monsters app? Or was it something else? Found it. Yay! Welcome, Pinak. Just subscribe PogChamp. What is PogChamp? Not very familiar with this Twitch stuff. Oh, with Prime. Thank you for subscribing. I watched the web dev challenge. Oh, cool. I had so much fun on that web dev challenge. If you all have not seen that web dev challenge, you gotta go watch that. It's a really fun episode where Jason, hold on, let me find this. Where is this? There it is. It's a really fun challenge where you are given 4 hours to build something. Where you're given 4 hours to build something and you have to build an app within 4 hours. But you would think that 4 hours is enough time to build an app, but when you're actually building it, it is so stressful. When I started building the app, I was like, maybe I'll be able to finish it. I hope I can finish it. So I'm going to start off with like a basic version because I have this habit of procrastinating and I have this habit of being overly optimistic with my skills. So I was like, I'll build a shitty version, then I'll make it pretty. And I was able to get the shitty version done within like the first 30, 40 minutes. I was really happy. I had this bug in the code where if you like search for a monster, you would see that same monster everywhere. So it wouldn't show you like different monsters. So I was able to fix that bug within like another hour. But after I did that, I was like, thank God I fixed this. So then I went on to make it pretty. And finally, I was able to have a working demo. Just 10 minutes before the final demo, I had another bug in my code. And I was like, oh my God, am I not going to have a working demo again? But then finally, within the last 10 minutes, I was able to fix it. So I was like, oh, thank God. So it was a roller coaster. But I had so much fun building that. And that was the first time that I also worked with convex database, which I had a lot of fun experience with. Um, it made integrating with database really easy because you literally just have to put the provider in React code and everything else would be taken care of. Like your connection is set, you don't need to make any fetch API calls. So you just like retrieve from the provider and it was there for you to consume. So it made my life a lot easier, and I was a big fan of Convex from there. So I had a lot of fun in the Web Dev Challenge. But if you haven't watched the Web Dev Challenge, go watch it. It's so fun. Um, Jason hosts these Web Dev Challenge periodically, and if you are interested in being part of the Web Dev Challenge, you can join as well. I work in IT myself. I have been watching a lot of developer content, working on relearning Python and Bash. I'm making transition to DevOps or DevSecOps, hopefully by end of this year. Oh wow, really cool. Like I have briefly worked with Python myself, and with this AI stuff, I feel like I have to relearn that as well because everything is in Python. It's much easier to get like stuff or like tutorials within Python. So I'm thinking of relearning Python as well, although it's easier to pick up. I'm I'm looking to transition to DevOps or DevSecOps hopefully by end of this year. Pinak, I'm curious what makes you transition to DevOps? What gets you interested in DevOps? Hello, Zorba. Nice to see you here. Yeah, after I watched your episode, I went back and watched all the season one episodes. Yeah, they're really fun. Um, it's kind of stressful as well, but it's really fun. I love being on the show. Jason and I did another show, which is going to come out soon. So if you haven't yet subscribed to Jason's channel, you got to subscribe to his channel because he makes awesome content. Speaking of which, I'm going to share his channel. Langstar's channel. Jason is one of my favorite people. All right, back to content-based filtering. I'm going to hide this and show you the link that we're reading. Where is the link? This is the link. Okay, to demonstrate content-based filtering, let's hand engineer some features on the Google Play Store. The following figure shows a feature matrix where each row represents an app and each column represents a feature. Each row represents an app and each column represents a feature. Okay. Features could include categories such as education, casual, health, the publisher of the app, and many others. To simplify, assume this feature matrix is binary. A non-zero value means that the app has that feature. Okay. You also represent the user in the same feature space. Some of the user-related features could be explicitly provided by the user. For example, a user selects entertainment apps in their profile. Other features can be implicit based on the apps that they had previously installed. For example, the user installed another app published by Science RS. Okay. The model should recommend items relevant to this user. To do so, you must first pick a similarity metric. For example, dot product. What? Then you must set up a system to score each candidate item according to the similarity metric. Note that the recommendation was specific to this user as the model did not give any information about other users. Using dot metric product as a similarity measure. Consider the case where the user embedding X and the app embedding Y are both binary vectors. Since XY is what the what is this? Uh, uh, college math. A feature appearing in both X and Y contributes a one to the sum. Um, In other words, xy is the number of features that are active in both vectors simultaneously. A high dot product that indicates more common features, thus a high similarity. Okay, so one is x and app and y are both binary vectors. Since this is equal to sigma I to d x y, a feature appearing in both x and y contributes a one to the sum. In other words, x comma y is the number of features that are active in both vectors simultaneously. A high dot product that indicates that more common features, thus a high similarity. Okay. So try it yourself. Calculate dot product for each app in the preceding app problem, then use that information to answer the question. Which app should we recommend? Casual app created by time waster. Time waster is this. Casual is this. Uh, what is this? A health app created by healthcare. Health app created by healthcare. Or an educational app created by Science RS. Created by Science RS. I don't know. Health app created by healthcare or educational app created by Science RS. Oh, Ronit says summation. Health app created by healthcare. They're all kind of in the same matrix. They all kind of have one in here. I don't know. Let's try. This app actually has the lowest start price is zero. Our user isn't interested in casual apps like games. Let's see. Casual. Oh, wait. I think it's the number of preferences in the same. Okay, let's try this. Health app created by healthcare. Healthcare has two, and health has one. So that might be three. This app scores a one. It isn't the worst recommendation system could make, but it certainly isn't the best. And then educational app created by Health Aras, one, two, by Science Aras, and this is so there's one, two, and one, two, four. So this would be the best one. Item has the highest start product two. A user really likes science and educational apps. Interesting. So let's find out why casual and favorite time waster is zero. Casual is here. Time waster is here. There's only one here. I don't think I understand this. I don't think this should be zero. Why is it zero? Hmm. I've been stuck in IT support wheel for a while. I feel like DevOps will be the new IT support once AI kind of gets more integrated in the companies. I totally agree with you. I think DevOps is definitely a better place to be as opposed to be IT support. And DevOps also has a lot more avenue for you to grow in as well for your career as opposed to IT support. So if that's the route you want to take, I think this is a good decision. I have an idea, but I'm still flushing it out. I'm looking to do something in the fantasy sports side with machine learning and AI. That's really cool. Um, what are you looking to build? Also, I want to move away from customer facing roles. Been doing IT support and help desk for about a decade. I feel you, Pinak. I think DevOps definitely would be a good space for you to do if that's what you're interested in. It's nice that Google has this recommendation systems as a complete course. Oh, okay. So this course assumes you have completed machine learning crash course either in person or have your knowledge familiar with linear algebra, inner product, matrix vector product. Maybe it's time to actually um, refamiliarize myself with inner product and with matrix vector product because I've totally forgotten all of that stuff. Let's see what's in this machine learning crash course. This is the one that we are working on. Embeddings. Okay, I think this is a really good time to put a pause on this for today. Tomorrow I'll be back at 5 p.m. working on the same stuff. I think tomorrow I'm gonna dive bit deeper into machine learning because this stuff is still new to me. So I'm pretty unfamiliar with this. So tomorrow we're going to learn more of this. It's nice that building recommendation engine is taking me deep into the weeds of machine learning. So that's just how learning goes, and I'm excited to do this. If you are new here, I just want you to know that this is day 4 of 30 day of live streaming with me. I will be live streaming every single day in January to kickstart this year at a high note. Today is day 4. Tomorrow I'll be back at 5 p.m. Pacific time, same place. If you haven't subscribed, please subscribe and like. I will also be publishing another video very recently. Very recently, I'm publishing a video very soon on how to build an OpenAI app. So all of this stuff that I'm showing you, I will be creating a video on this. Um, so creating this kind of like integrating with OpenAI through LangChain, fetching data from like parsing the result, parsing natural language text into a JSON object, and sending it over to the LLM, then getting the data back from LLM, consuming it on the front end, and creating this front end application. All of this is covered in a video, which I will be publishing very soon. Actually, after this video live stream ends, I'm going to go and record that video. So if you're interested in OpenAI and interested in integrating with OpenAI through LangChain, you have to watch that video. I am so excited for that. But this is all I have for you today. I will see you tomorrow very soon at 5 p.m. PST. I hope to see you out there. Please come and join me tomorrow. And until then, Happy New Year. I hope this year brings you lots of success, happiness, joy, and I hope this is a really good year for your mental health and for your career. Thank you for joining me today. I will see you tomorrow. Bye.